Differentiate f of x equals x minus e to the x, g of x equals x to the e plus e to the x, and h of x equals c e to the x plus d. Again, we have three different functions that we want to differentiate. I just want us to get practice dealing with e to the x in different scenarios. So let's differentiate each of these. Let's start off with f of x equals x minus e to the x. If we want to differentiate this, we can do this one term at a time. The derivative of x is 1. There's different ways we can think about that. X is the same as x to the first, and so if we're using the power rule, we bring the 1 out front, and the derivative, when we subtract 1 from the exponent, x to the 0 is just 1, so 1 times 1 is 1. The other way to think about this is y equals x is a diagonal line with slope 1, so of course the derivative is going to be 1 because that is its slope. And then we have minus, and we have to differentiate e to the x. But remember, e to the x is the function whose derivative is itself. So the derivative of e to the x is e to the x, and our overall derivative of this function is 1 minus e to the x. Let's move on to g of x equals x to the e minus e to the x. We want to differentiate this. If we look at the first term, this is a power of x. So we use the power rule. We bring the exponent out front. So e times x to the e. And we subtract 1 from the exponent to get the new one. 1 subtracted from e is e minus 1. So we've got e times x to the e minus 1 minus, and again, the derivative of e to the x is e to the x. So we've got e times x to the e minus 1 minus e to the x. Oh my, feels complicated. Can be tricky, but if we go through these things slowly and use the right logic, we should be fine. Let's look at our last one. H of x equals c times e to the x plus d. This is a function of x, so c and d effectively act as constants. So let's look at differentiating this. If we go term by term, remember that when we have a constant times a function, when we're differentiating it, we can pull the constant out front. So we pull the c out front, and then we differentiate the function that's left over after we get rid of that constant multiplier. The derivative of e to the x is just e to the x. So we have c times e to the x, and then we add the derivative of the second term, but the derivative of a constant is 0, so we don't have anything to add, so the derivative here is just c times e to the x.